So again, y is all by itself. When y is all by itself, that's the only time we have a y-intercept and a slope. The y-intercept is always the number all by itself, not with the variable x, or any variable. The slope is the number with the variable, which is going to be the x, typically. X is not part of the slope. A lot of people lost points on our last exit ticket when I just said, hey, just tell me what the slope is and what the y-intercept is. I said 3 or 4 times, the x variable is never part of the slope. A bunch of people wrote x in. Marked them all wrong. Every single one of them if you did that. You've got to know x is not part of the slope. We're past the point where I give you a break on that. This equation is y equals 2 times x, that's what 2x means, subtract 3. They are separate numbers. I mean, x is an unknown number, but it's still a number. So 2 is the slope, not x. So you need to write that down every single time I say it, because you're going to see it again. Not on this exit ticket. You need to know the number in front of the x is the slope, and x is not part of the slope. It's a separate number. All right. Like I said, whenever you don't know something, you should be writing it down every single time. I don't care if you've written it down 10 times. If you don't know it, clearly you need to write it down again. So we don't need to do that. All right, so you should, if you did not grab one, come grab one of these. This is what we're working on today. That's your practice. So come grab one if you didn't get one. Anybody? All right. You have one, Jordan? Did you grab one of the worksheets? All right. So here, copy this down too. Let's just go ahead and do this. We'll just do the notes part first. I'll zoom in. So we're going to be shading and doing a dashed or solid line. You got to know when to do that. So this is, I explained why you do it on Monday. Today I'm just telling you how to do it. Here's your shortcut version. If you have these notes, it'll get you through my exit ticket. You won't have anything like this on the end of course exam next year, so you need to understand it next year. But for my exit ticket, this will work. So I'll give you, once you're done, just put your pencil down so I know you're all finished. Yeah, again. Well, but they've been recorded. They're not one go. All right, so I'm imagining you're pretty close to done, if not done. So these are the 3 steps you're using today and on the exit ticket. The first step is really multiple steps, but we've done it a whole lot, so I only made it 1 today. So when I graph in a minute, I'm following these 3 things. This is what you need to know how to do by Friday. The second 2, well, the middle one is a piece of cake. All you got to do is look at the symbol, and that tells you what your line is going to line up looking like. And I'm actually going to give you a little sort of shortcut that will at least get you some points on that no matter what. Number 1 and number 3, you got to figure out. Anybody still writing that? Done? Still writing with me? I mean, it's also being recorded, so if you miss anything today, you can always go back and watch it. Hopefully it's being recorded. That's why I don't want to. You know that she's just going to the bathroom and going to meet her boyfriend. All right. Again, I'll use these. I'll refer to them, so you should have them written down. Make sure you can find this. I mean, it's only 2 days away, but still, sometimes we take a lot of notes then around the stuff that we've already written, and we can't find the other stuff. So this is one of the types you're gonna. There we go. So you just missed the notes on one part. Got to get them. So now we have y all by itself. So again, there's 2 types of graphing, y all by itself, and then when y is not all by itself. So if y is all by itself, what are you doing? Y-intercept.
Write this down.
You know it, you know, I mean, if you don't know how to graph, then yeah, you need it right now. Again, you have to take the exit tickets. I can't tell you what you know and you don't. Based on what I've seen on exit tickets, not many of us know it. So I'd write it down. I don't believe there's anybody that's crushed graphing in this class. Some people get more points than others, but they're not. I don't know if there's anybody that's been getting 100% on the graphing. Maybe 1, 2, but I even now. So our first step, we say, once we've identified that we have a y-intercept and where the y-intercept is, boy, let's go ahead and put earbuds and phones up. So I saw earbud over there, so Karina, nothing there, so you're hiding one. Let me see. Yeah, let me see both ears. Put them all the way back. Take it out. Let's see, it's red. Take it out. Don't lie to me. Why do you lie to me? I hate it when I get lied to. So you take yours out, Katarina? Again, when we get our grades right, when I feel like people are actually doing what I asked to do, well, I'll be maybe less strict on that again. And please don't lie to me. That's the worst thing you can do. So now that we've identified y-intercept, or y is all alone, so we have a y-intercept, that is your first step. That gets you points right there. I don't give you points for identifying it, but I do give you points when you put it on the graph. Please don't let me find that. I will check you later. All right. I don't want to see it back in, so it shouldn't even be in your hand. I've already had that conversation. So now I need a second point. I guess this is the tougher part. I'm still gonna get tough. There's no real math involved. We need to take the slope. That's the number in front of the make sure you're including symbols with the numbers, or not symbols, math operations, negatives, positives. Subtraction is really a negative, positives, or addition's a positive. We're still forgetting that the sign in front of the number, doesn't matter what's behind it, the sign in front of the number is glued to that number. We're making all kinds of mistakes on that, whether it's doing something like this or doing math with the number. You've got to remember, if you need to write it down again right now, write it down again. Sign in front of the number is glued to that number. Every time we use a number 3, we're going to use that negative sign. Every time we use 1/4, we're going to use that negative sign. If we solve for anything in a problem where there's a negative or subtraction, we're going to use that when we do the math. So we take the slope number. If it's a negative number, so we have a negative 1/4, we make the top number negative. If it's not a negative number, if there's no negative in front of that fraction, don't make anything negative. Sometimes people are trying to put a negative number in there when there wasn't a negative number. You don't create a negative. You only include the negative with the top number if there's one in front of the whole fraction. Now, next to that, so this is, by the way, we're doing the first step where we put the 2 points on the graph. So this is still the first step. Back here, we're putting the 2 points on the graph. But as you can see, there's more to it than just writing 2 points. Now we put rise over run. Again, same thing we did for weeks and weeks and weeks, months and months and months. And we say, okay, I've got my slope number. I now have a rise and a run number. Just follow the directions right there in blue. Positive run, count right. Negative run, count left. Positive rise, count up. Negative rise, count down. So from the y-intercept, I don't start up here. From the y-intercept, the first point I already put on the graph, I count right 4, because that's a positive 4. I count right 4. 1, 2, 3, 4. I hop 4 is what I also say. And then I count down or hop down 1. That's my second point. So we have now done step 1 of graphing an inequality. We have our 2 points on the graph. So if we go back, actually, yeah, we'll go back. So now we can go back and look at the second step. And I wish I would have probably done this differently. And every year I say that. I would really almost say the second step can kind of be done first. Now you can't draw the line until you know where the 2 points are, but here's what you can do. And I will give you points for this if you do this, even if you wind up doing something wrong at the end and you forget about it. I'll explain it when we go there. If I look at this problem before I even graph the points, I know whether or not my line is going to be solid or dashed because it's just based on that symbol. It doesn't matter where the points are. All that matters is this symbol has that little or equal to thing underneath it. That means my line is going to be solid when I draw it. If you get your exit ticket or today on your worksheet, you can do it right now or before you start. You can do it for every single problem. Just right above the equation, well, if it's that symbol, it's going to be a solid line. If it's the symbol without that little line, one of the 2 symbols without that little line, it's going to be dashed. You can do that at the very beginning of the problem. And if you happen to forget when you make the line itself, I will still give you credit because you at least checked it at the beginning of the problem. Yeah. All right, so now that I've checked it and I've said solid, I would draw a solid line through those 2 points. Remember, just check it at the beginning, look at the symbol and write solid or dash before you even worry about doing the 2 points. And then hopefully it reminds you when you make the line to make it either solid or dashed. If it doesn't remind you, at least I know you checked it at the beginning and I can still give you credit probably for it. On an exit ticket at least. I don't know if I'd do that on a big quiz, but I probably would on an exit ticket. So now we have our line. So that was step 2. Draw a solid or a dashed line through the 2 points. The last step is probably the most complex. I still don't think it's super difficult because again, there's a process. You just follow the process and you're good. We need to figure out which side is the solution side. Where are the answers at? Which side do we shade basically? What did we say about the shaded side? You got to know this for sure also. Yeah, the shaded side are all our answers. Every point on the shaded side is where our answers are. And there's no point on that side that won't work. If it's the shaded side, every point will work. If it's not the shaded side, no point will work. So one side we're going to shade, one side we're going to leave completely unshaded. And it's based on where the answers are. Like we need to figure out, okay, which side has the correct answers. And we only have to test 1 point. If that point is a correct answer, in this case, that would mean that that X and Y value would make the left side less than or equal to the right side. If it works, then that's the side we're going to shade because every point on that side will work. If 1 point works, every point works on that side. If it doesn't work, then there's no point that will work on that side. So hopefully you understand that because there are some understanding type questions on the exit ticket. I'm going to have to zoom out a little bit for this. So here's what we do. We pick any point we want. Not a risk. Good man. Good man. Oh.
Like I don't always.
Not what? You just missed the whole class so far. You need to be in here doing what we're doing. Something. You drive me crazy. Tell us, hey, Mr. Gill's mean, can't text you. Fine with that. If she wants to have a conversation about it, more than happy to talk to her. Actually, that's what I should do. Every time a student says that, they need to go on my list of parents calling. No. See if they keep texting their mom. I don't think they want me to have a conversation. All right, so I need to find, or I said I only need to find a point that works. I don't care if it works or not when I test it. Because if it doesn't work, then I know that side doesn't get shaded and the other side gets shaded. So it doesn't even matter whether the point works or not. I just need to pick a point to test. Somebody give me a point. Any point. Tristan, give me a point. Why do you want to give me negative? It's going to make it hard on Mr. Gill. All right, -5, but you got to give me 2. I need a x and a y. -5 and y.
And 4.
Oh, killed me. Oh, actually, wait. 4. Nope, 4 is going to make a pain in the butt. That's all right. Luckily, Tristan, I'm pretty good at math. All right, so Tristan said, let's test this point right there, because he said -5 is a fun number. He said, I want to know if that point works. If that point does work, every point on that side will work. If it doesn't work, then no point on that side will work, and every point on the other side will work. So in order to test that point, I'll change this so you can see it a little better. That point is -5, 4 is what he wanted to test. So I just need to say, okay, well, this is my x value that I'm testing, and that's my y value I'm going to test. And I just plug those two numbers into the original inequality. And I see what numbers I get at the end, and I need to determine, is that true or not? Did it make it a true statement? So let's plug them in. Y is 4, so I put a 4 there. That's got to be less than or equal to -1/4 times -1/4 x means multiplication. So x is, I'm going to go ahead and change that into a fraction because we need a fraction times a fraction. We don't really need it, but it makes it easier to understand. And then subtract 3 is just the rest of the equation at the end. So 4 is always just going to be 4. There's no math to do on the left, so I'll just bring the 4 down. Now I can multiply multiply and then subtract on the right. So thanks to Tristan, we got to deal with a whole bunch of negative stuff. A negative times a negative is a positive. So that gives me +5/4. And then subtract 3. I don't even really have to know exactly what that's going to come out to be, because no matter what this is in a decimal, when I subtract 3, I'm going to have a negative number. Because this is going to be just, well, it's going to be 1.25 if you want to know the exact number. So that would mean I would get 4 is less than or equal to -1.75. Now, when you get to the point where you have one number on both sides and then a symbol in the middle, this is when you ask yourself a big question. This is a $1 million question right here. Top right. Is that true? Is 4 less than or equal to, is it equal to it? Are they equal?
No.
Not equal. Is 4 less than -1.75?
Yes.
4 is less than -1.75?
Oh,
No, if you are struggling, especially when you get negative numbers, the lower the number, the smaller the number. The higher the number, the bigger the number. So 4 is way up here. -1.75 will be like down here. So this number is much smaller than this number. So 4 is not smaller. 4 is greater than. So that is a false statement. It's not true, whatever you want to. I write false. So you write down false. That's false. I came up with a statement at the end that was false, meaning that point that I used, that Tristan made me use, did not work. So here's what you do. You say, all right, well, if it's false, I'm going to make sure I write, oh, messed that up. Tristan gave me a point I'm not used to using. You write false right across where you tested, whatever point you tested. So he made me test that point up there, so I write false. Remember, you only have two options. One side is the solution side, one side is not. There's no combinations of anything. So it's either one or the other. So if I write false over there, what do you think I'm going to write on the other side of the line?
True.
Yep, that's pretty, I would hope that's pretty intuitive, right? If one side is false, the other side's true. So that's your next step. I don't really have that written in all the 3 steps for shading. Now your last step is you shade where it says true. That's the side you shade. So wherever you wrote true, if you wrote true first, like if this came out to be a true statement and you wrote true by the point you tested, then you would shade where it said true in that. For me though, the other side of the line was where I wound up writing true. So I shade down. Now you didn't have that one on your sheet, so I hope you're not looking for it on your sheet. You go through the same steps. I'm going to show you one thing real quick, then we got to move on because I got to still show you the other kind of graphing. Tristan made it really tough on me, or tough on himself if he's the one doing it. I had to multiply a fraction, not only a negative fraction, but then I had to multiply that by a negative number that Tristan gave me. And then I got a fraction, so I had to combine a fraction and a negative number. It's a lot easier than that if you pick the correct point, or if you pick a better point. There's no correct point, but there's one that's a lot easier, or the easiest, I would say. What do you think the easiest point is? 0, 0. So let me show you what happens if you pick 0, 0 instead of any other number, really, any other point. So if I use 0, 0, now 0, 0 still should not work, because remember, this whole side shouldn't work. So if I test 0, 0, which is right there, still shouldn't work because it's on that side, and we tested a point on that side and it didn't work. So it still shouldn't work, but it just makes my math way easier. The left side doesn't really matter too much because it's 0, and we're still not going to do any math over there. But watch what happens here. Negative 1/4 times 0. What's anything times 0?
0.
It's just 0, right? So if you've got a really difficult number to work with right here, it gets rid of it. It makes it go to 0. So that goes to 0. Now I have a much easier problem to finish. So what's 0 subtract 3?
3.
Nobody's right yet. I heard a 0 and a 3. Still not right. 0 subtract 3. Negative 3. If you have nothing and somebody says, nope, you owe me money, you get a bill in the mail, give me $3, you're negative. You owe money. You're negative 3. I don't think I'm giving you calculators on this one, so you need to know how to do simple positive and negative numbers. So now I get, again, a number on the left, a number on the right. Is that a true statement? Is 0 less than or equal to 3? Is it true?
Yes.
So 0 is here.
No.
Negative 3 is here. Which one's bigger? Higher. The higher number is bigger. So is 0 less than negative 3? No, 0 is higher. It's not less than, it's greater than. So that is still, and it should have been false. We said that earlier. Every point on this side should be false. So that also was false. Then we would have written false across where we tested. We would have still written true on the other side. So it doesn't change your result. It just makes your math easier to get the result instead of having to deal with negative numbers or fractions or whatever. Any questions on that? I mean, we've done most of that, just the shading part, and I guess the solid and dash, but that's easy. You just look at the symbol. All right, so I'm going to run through the last one. The shading part and the line part, these 2 steps here, they're the same no matter what kind of equation it is. You're always going to look at the symbol and say solid or dash, and you're always going to plug in 0, 0, get one number on the left, one number on the right, and then just say, is that true or false? The only thing that changes if you get a different type of equation is this first step. So I'm going to do the first step mainly, and then maybe quickly we'll do the other one. So I need to come up with 2 points. I don't have a y-intercept and a slope because y is not all by itself. That is not a slope. That is not a y-intercept. Y is not by itself. We don't have a slope and y-intercept. We need to do the whole plug in 0 for x. So what if x is 0 thing? Well, if x is 0, That's 2 times 0. I just have the rest of the inequality. 0 subtract 3y, not less than or equal to. Oh, there. So then less than 12. This is attached to that number, so I bring down the negative sign. Don't forget that. That's a big mistake people are making. Now when I divide, same thing. That negative sign is attached to that 3, so I divide by negative 3. That's another big mistake. So my first result or answer or whatever, why do I keep writing equal? First result I get, why? Technically it actually would be greater than, I guess. It doesn't really matter because I need to flip the symbol if I divide by negative. It doesn't matter because I'm putting a point in the same place no matter what. I'm putting a point on where y is -4. Or technically it's 0, -4 really. But if you just look at the y, -4, I put a point there. That's my first point. Now I repeat that same exact process, only I make y equal to 0. I say, well, what if, because all I need is 2 values that would make this side equal to 12. Even though that's a less than symbol, the line itself is where everything, the left side equals the right side. So now I say, what if y equals 0? If you're not following this, it's recorded. There's actually other lessons where we did kind of the same thing. So if y is 0, now I have 2x subtract 3 times 0 because I made y equal to 0. And that is less than 12. So that all goes to 0. 2x subtract 0 less than 12. So 2x less than 12. Divide by 2. Divide by 2. Hopefully that works. Yeah. X is less than 6. So now I go to where x is 6. Doesn't matter that there's an inequality sign because the points, remember, the points on the line. So when we're going to create the line, the points that we're going to use to create the line have got to make the left side equal the right side. It doesn't matter what the symbol is. The symbol comes in when we shade. That's what the symbol takes care of. We always want to create the line based on the left side equaling the right side. And then we make it oh, shoot. Well, I'm on that step right now. Do I need to make a solid or a dashed line? Dashed in this one, right? There's no little equal to, so I should have checked that at the beginning, and I kind of forgot. As long as you remember to do it, though. And the reason that these points are not solutions is because all the points on the line will make the left side equal the right side. Well, that's not good. We don't want that. We want the left side to be less than the right side, not equal to. That's why we're making it dashed. That's why that symbol is a dashed line. So if you don't understand that, just make sure you have your notes and you know which symbol means solid and which symbols mean dash. So there's my line. And then the last step, how can I do this? I want to make a little more room. Yeah, that'll work. So the last step is I need to test. Yeah, we'll use black. That's fine. I need to test and see, does 0, 0, again, you can test any point you want. I'm going to test 0, 0. The only time you can't test 0, 0, by the way, if the line goes through 0, 0. You have to test a point not on the line because you're going to shade one side of the line. So I need to say, okay, well, if I'm testing 0, 0, then I just plug in 0 for x, 0 for y. So that's 2 times 0, subtract 3 times 0. Here's why you want to do 0, 0, especially in these problems. What do I get on the left side? I'll do the math. What do I get? What? 2. Oh, you said 0. Yeah, 0. You will always get 0. Because you're always going to multiply the variable, which is going to be 0, times whatever number is in front of the x. And here, you're always going to multiply 0 times whatever is in front of the y. The left side will always be 0. You really don't get much easier than that. I don't care how complex the first number is, it's always going to get multiplied times 0. The left side is always 0 in these equations. So I'm just going to compare 0. Is 0 less than 12? Is 0 less than 12? What's my call? Yes, it is. So that's a true statement. Once I plug in 0, 0, the final statement, I guess I should write it. Taking shortcuts. That over there. So I would get 0 is less than 12. And again, that is a true statement. 0 is less than 12. So I would write true across where I tested, which was 0, 0. I'd write true. So what do I write on the other side?
False.
Write false on the other side. And I always shade the side that says true. So I would come up and I would shade the top half of that line. That would be my final. Every point in that shaded side is a solution. Because every point in that shaded side will make the left side less than the right side, which is what our inequality is saying. Left side has to be less than the right side. Every point on the bottom of the line will not work. None of those points will make the left side less than the right side. All of them will make the left side greater than the right side. And then the points on the line would be where we would get 12 here, which doesn't work either because it's not less than 12. We could test. Is there a point we could test? No, not really. Maybe. We could go 1, 2, 3. Yeah, we could test 3, -2 should make the left side equal 12. So 3 would be 6, -2 would be 6, so 6 plus 6 would be 12. So that's because that's on the dotted line. But again, we don't want the left side to equal the right side, so that's why we still have a dash line. All right, so go ahead and practice. You've got 50 minutes. That's a lot of practice time for a 4-question exit ticket. Yes, sir. Yeah, I don't think anybody was there.
I go next.
Yep. So I'm gonna walk around. I'm gonna help. You better be working. I'm gonna do attendance real quick, I guess. Get that out of the way, and then I'll start walking around. That way, I don't have to worry. So I'll leave. Actually, let's do this one first because I think most of the problems are like this one on the front page at least, and then I think on the back page they have a few. Oh, you don't have to do number 4, and you don't have to do no. There's one on the back that says X is less than or equal to or whatever. So you don't have to do 7 then. I'll just tell you the ones I would make sure I did first.
What about 11?
Number 1, number 5, and then number 9 and number 10. Those are the ones I make sure I knew how to do. On number 9, you'll get a decimal. So when you go to solve, so number 9 is like this, where you have to plug in 0 and solve, and then plug in 0 and solve. When you solve for one of the variables, I think it's X, you'll get a decimal. You actually get, it's 3.33333, or 3 1/3. You get the fraction first. That's fine. When you go to put it on the graph, you would just go to where the 3 is. But you wouldn't put a point on 3, you'd put it a little bit to the right of 3. Still the same process. It's just you're not putting a point right on an integer, you're putting it a little past the integer.
What about 11? Because this one says right is.
11 should be fun. Oh, so 11 is just like 4, yeah. So yeah, you don't have to do 11 either. I'm not saying you'll never have one like that, but they won't be on this exit ticket. You've done those before, where you just have one number on the other side from Y, but I didn't. Again, there's only 2 graphs. There's only 2 problems where you have to graph. Then I ask you questions about something I've already done for the other 2 questions. So you have to have a little bit of an understanding. Oh, I was doing it too. So that's the, what we did in red, don't get confused. Remember, actually, I'm going to erase that. I tested a point that Tristan gave me first. Well, still missed it all, but that's fine. I guess I'm good. That's slow. There. So now that's cleaned up. Well, I guess I can stop the recording.